Hello, I'm Derick. I'm European. That's a bit of a long story. Talk to me about it later if you must. I work for a company called MongoDB. I work as my day job on the MongoDB PHP driver. I'll be talking a little bit about that this morning. Later in the day, I have a talk about Xdebug. I think it's at 5:10, if I remember correctly. I like maps, I like beer, I like whiskey. Some of you might have noticed me having a few beers with you last night. Some of the examples, we'll get back to those subjects as well. I don't think I'm going to have enough time to do questions during the presentation. We might have a little bit of time afterwards, or otherwise you can find me in the speakers lounge after this presentation, where I'd be more than happy to come and answer questions that you might have on any of these subjects. All right, so let's get started. So MongoDB is not a relational database, right? It's a database that stores data in different things. And because it is a non-relational database, we use sometimes different terminology, different terms to describe what kind of things we're storing and how we're doing that. So if you're familiar with a relational database like MySQL or Oracle or PostgreSQL, any of these, they tend to want to store data in records. Well, the record is the smallest unit of information you get to store. In MongoDB, we call those documents. Documents are then stored in collections, which you probably call tables in a relational database. And they represent a collection of documents, really. Indexes are the same as in relational databases. They are just as important. If you forget them, things will be slow. If you have good indexes, things will be fast. It should not really be a surprise there. I'll get back to all of these points during the rest of the presentation, except for the last one, which is sharding, which is a way of partitioning a set of data into multiple blocks so that you can store the multiple servers. But with the few bits of terminology out of the way, let's get going with what this actually means. So the first thing to talk about is documents. Now, documents are not the kind of documents that I have here on the back of the screen. They're not handwritten, they're not Word documents, they're not Google Docs documents. The documents that I really mean here are bits of information that store key value pairs. So let's have a look at a very simple one here. So in this document, we have a bunch of fields. So the first one, the _d one, is it's a unique key of this document. So this is a field that every document needs to have, and you cannot change it. So you can't update this document to change this key. And then all the other fields in here are, well, key value pairs, right? So we have, need to point out that all the strings are UTF-8, so you never have those annoying character encoding issues anymore. But that's just a very simple one. But the interesting thing is that because MongoDB is a document database, is that those documents can be quite more complicated sometimes than simple key value pairs. So in this more complex document, we again have this _d field, but it's now not this auto-generated number from the previous slide. It is something that you can set yourself. So if you already have an ID, in this case I use my email address, which is going to be unique for the rest of my application, you can just set that yourself. Or for example, the words field here is no longer just a simple string, but instead it's an array of values. And in MongoDB, you can construct queries against words directly. So you can do, as an example, select star from table or collection where words equals London, and it would find this document even though it is a part of an array value. So you can do queries directly against that, which is kind of handy. This is, of course, a whole lot better than storing things in a comma-separated string, like I'm sure many of you have done in a relational database at some point in your past. I certainly have. So besides storing arrays, it's also possible to store arrays of key value pairs, of documents again. So what I have here in the bottom, I can only point to one screen at the same time, sorry. This is an array again, and each array is a document with 2 key value pairs, right? So there's N for unique and L with a number. So those little bits of document in there, they are part of the overall document. They don't exist on their own, but they can sometimes be really useful to store extra information. Like what I've done here for this example here, it is me as a user, and then I've earned some badges in whatever quest I've been going on. And I can store those as separate, as part of this single document. Another good example would be here to store all the phone numbers of one person in an array in a single document, so that you easily have them available when you look up the user without you having to make joins, for example, because NoSQL databases like MongoDB, they don't tend to support joins at all or foreign keys. They solve that kind of data modeling instead of making relations between two collections or between documents in two collections by storing the data that belongs together in one single document, which is what the badges do here, or what you can also do with phone numbers or addresses, for example. All right, so those collections are kind of important as well, because that's why we store all the documents in. And the collections here are interesting because the documents in one collection do not have to have the same form. They will always have an _d field. Every document will have one. But if you look at a collection of, say, whiskey distilleries that I have here, so there's a bunch of fields that are the same. The field names exist in both documents, right? So the slug, the name of the distillery, the region of the distillery, they are fields that are in all documents. So those are usually the fields that you do queries on. So find me all the whiskies in the Highlands of Scotland, for example, or find me all the whiskies of the distillery Suntory, which happens to be in Japan. But besides those fields that you end up doing the queries on, you can also store additional fields that don't always have to exist for each document. In a relational database, often because you have to define a schema up front, you will have to define that these fields exist, but you then have to declare them as being possible to be null, right? Whereas in MongoDB, those fields, they simply cannot exist. So there's no reason, there's no need to create a table with a specific definition up front, or in our case, you don't define which fields are part of the documents in a collection. Because if you really want to, you can insert any sort of document you want into collections. Now, that's not what you should do. A collection is still meant to always have the documents of the same sort of thing you're storing. So in this case, whiskey distilleries or books or products, they all go in one collection. You wouldn't put users and books or users and whiskey distilleries in the same collection, because that makes no sense for setting up queries or indexes, just like you would not do that in a relational database table. All right, so indexes can be made on collections, just like you have indexes made on tables in a relational database. But because the document itself is a bit more complicated sometimes, you can also set indexes on those more complicated fields. The _d field will always have an index set on it. You cannot remove that or create it. It's always there. You can set indexes on just a single field and enforce that there are unique fields, like you can in a relational database. You can set indexes on things that have multiple values. So the styles like single cast, there will be many of these values that are matching between all of the documents. So it's a non-unique key. But you can also set those indexes on those nested fields. So it's possible to create an index on the attribute.date field, which is kind of handy in some cases, because it allows you to index fields in arrays as well, like I'm doing in the last bit. So if I create an index on words, it will automatically create an index key for each of those 5 words, or 4 words and 1 number, in this from this field, so that you can do index lookup against these fields, which is something you cannot do in a relational database, because, well, you need to come up with a way of converting your array or your string with comma-separated values into an array in the first place, so you can't do that. Which is really quite a powerful way of, in this case, what I'm trying to do. It's like all the words that describe a specific distillery are now words as part of this array. And I can do a lookup against that and find it's like a very simple way of doing like a full text search query, right? Which MongoDB has also as an additional feature, but in a very simple, basic way. This works pretty well. And especially when you want to do like lookups as you are typing, for example. All right. So this being a PHP conference, I probably should talk a little bit about how you talk to MongoDB from PHP. This is quite a complicated schema. It isn't actually that difficult, at least as a user. The main important thing is that there is a driver and there's a library. The driver here in blue, actually should move that because we got rid of HHVM at some point. The driver is the extension that you install with PHP. So if you have the MySQL extension or the Oracle extension or the ImageMagick extensions, for MongoDB you have the MongoDB extension. So that's something you can install with the Packle install tool, and that will provide you with a very simple way of accessing the database. It will do all the connection management for you and things like that. What it does not do is give you a very nice interface for interacting with the database. For that, on top of this extension, we have a PHP library, which you can install with Composer. That has all the nice interfaces. It knows things about what collections are, what databases are. They have lots of helpers for creating indexes and so on, which is something that the extension does not have. Now, if you really want to, you can use the extension for everything that you want to do, but it's not going to be an easy way of doing that. All right, so just a quick slide to show you how you would do that if you actually have to do this yourself. Install the MongoDB extension by using Packle install MongoDB. Most distributions, Linux distributions at least, will have a package for the extension available anyway. If you're on Windows, we provide a Windows extension for you that you can download and just plop into your extensions directory, so you don't have to compile it yourself. So yeah, the first 5 lines really is how you would get both the extension and the library ready for you to use in your projects. And then the last line here being the composer line to add the library, which is MongoDB/MongoDB. After you have done these things, then in your script, you need to require your vendor autoload script, like you do with basically any use of a composer anyway. And then after that, you can make a connection to MongoDB, like we do with client is new Mongo client. And we can create a handle to a collection by selecting the collection by providing the database name and the collection name. So at no point, you're going to have to create a database or a collection because they get created for you the first time you insert a document automatically. So the driver and the library is what you're going to need, and most of the examples that I'll be showing you from here on will be using the library, although not necessarily all of them. Now, of course, once you have this handle to this collection, this handle is important because it is the only way how you would interact with a collection. All the operations that you are going to do are always going to be on one collection only. And on this collection, we have defined quite a lot of methods. A selection of them are here. They're not covering all of them. To do operations on this collection. So the way how documents look like on the PHP side, they are either simple PHP arrays, like I've done here. So there's a document that has one field, it's called name, and one value, canvas 26. This is my whole document. It's a document with one single field. Now, if we want to find all the documents in a collection where this name field is canvas 26, we call the find one method and get one document back. In this case, you'll get a standard class object back with with at least 2 fields, which is the _d field, because every document has one, and then the name field showing what the value of the name field is. And of course, all the other fields as well. Instead, if you want to find more than one document in one go, you use the find method. And the find method returns a iteratable object in PHP that for each you can iterate over to retrieve all the found documents from the database. Find will also take options such as skip and limit and sort and so on, but I've left those out on this slide because running out of space really. Finding documents is really fun and useful, but it's also important that you insert documents in the database first, otherwise you can never find them, of course. For that we have 2 methods, insert one and insert many. And as those names imply, they either insert one document or multiple documents. So in the first one with insert one, we're inserting one document where the name field is Glenfiddich 15, but because we don't specify an _d field, the driver will also automatically add that field for you because you haven't provided it. And then it will use this like long number that is sort of a GUID, but also sort of not. Similarly, inserting many fields, you specify an array of documents, which is what I've done in the example over here, right? So there's an array, and each array has a associative array in there that has a name field and a name value. Now, from what I've shown on this slide, I've only shown you arrays, but you can also use objects in here. Objects that you've created yourself, we actually have created some interfaces called JSON serializable that, BSON serializable that you can use like PHP JSON serializable to figure out if you have like your domain specific objects, how to convert them to something that you want to store in the database. So there's quite a lot of things in there. I would like to talk about that, but running out of time for doing that in this overview presentation. So insert one, insert many we also have update one and delete one, as well as update many and delete many. They basically do the same thing as find, but of course, deleting will not return you the documents, it'll just delete them from the database. If we do an update, then the first argument is the same as your find query, and I have a better example of that in a moment. And then the second argument is kind of interesting because unlike doing like updates like you do in a relational database, you have to provide a set of specifiers that operate on specific fields. So what the set operator does, it sets the value of the field age in this case to 26. Additional operators, of course, also exist. There's an operator called inc for increment, for incrementing a number without you having to query the document, modify the value in your application, and then store it back to the database. Because if you do things like that, you can have race conditions. There's methods that allow you to push things to the end of an array, which is kind of handy if you have a list of words already in an array. You can do push to add an extra element to the array at the end. There's also pull for removing things and so on and so on. There's many of these operators that can be very useful for doing all kinds of operations on documents when you're updating them. All right, so the query language in MongoDB is quite different from what it is in a relational database. So in order to make a small overview here, I've tried comparing a few queries that are quite common in a relational database, or in this case, probably MySQL, with how it would look like if you would run these operations on MongoDB through the PHP driver. So the select star from whiskey, we basically want to find all the documents and don't care which fields we get back, right? So if you do that in MongoDB, in a MongoDB library, you do find, you specify an empty query, which is an empty array in this case, and you don't have to specify any of the fields, because all the fields are included by default. If you only want to include some of the fields, we call that a projection. And a projection is not more than the second argument to find, where you then specify the field names as well as a 1 or a 0. The 1 means include a field, a 0 means exclude the field. You would almost never use a 0, except if you want to exclude the _d field, because if you don't specify the _d field, it'll get returned anyway. So you have to specifically turn it off by using _d arrow 0 if you don't want to see that. Now, queries are done by example almost. So in order to find all the documents where the age is 42, you specify what these documents that you're finding, that you want to find would look like, or the minimum amount of fields that needs to match. So what find age 42 says is basically says, find me all the documents where the age is 42. That's what that query does. Now, of course, you can create more complex queries that I've done in the fourth and fifth example here, is where we're trying to find all the whiskeys where the age is 18 or more. And the queries is a bit different there, because you don't specify that as just a simple string. You don't create a string like you would in SQL to create a query. No, instead you build like an array kind of structure. An array kind of structure where you first specify the field name, and then with query operators, how that field needs to match. So in this case, we have a greater than, meaning the number needs to be greater than 18, for example. By definition, all those elements that you specify in this document, they all need to match. It's an AND query by default. If you want to do an OR query, that sometimes happens, although you don't see them that often, I guess, then it gets a little bit more complicated. So what I basically want to show you with the nearly last example is that the query language is quite powerful. There's lots of different specifiers and operations in there, and it would be nearly impossible to find an SQL query that you wouldn't be able to represent in a MongoDB query. I'm sure you can find some examples, but there shouldn't be very many where you can't. Interestingly, the last example here is where I'm doing a join, a left join. And MongoDB's query language cannot do left joins or any joins at all. In order to do a join between different collections, you can do that, but not with the standard query language. In order to do that, you need to have a look at the aggregation framework, of which I have an example later down in the presentation. So the left outer joins are possible, but not directly in a normal query language. All right, so a little bit about the data model. Because it's very different from a relational database where you create your schema up front according to how your data looks best. You create relations between tables to make sure you have the referential integrity, your foreign keys, and so on and so on. Well, as MongoDB is a very different type of database, you usually don't sit down up front and create your schema according to how your data looks like in the best possible way. Instead, what you need to look at is how the application is going to interact with your data, and you model your schema according to that instead. While doing so, you need to take into account that there's no no relations between collections. There's no enforced foreign keys. There's no transactions. However, you can see I crossed it out, mostly because the next version of MongoDB 4.0 will actually have support for transactions in there, which is kind of cool. Unfortunately, the PHP driver hasn't been updated to make this work yet. That's my task next week. So unfortunately, I can't show you an example yet, but it is definitely coming in the next version, which I'm quite excited about myself, to be honest. All right, so well, not having foreign keys or relations between collections, well, how would I model the data in that case, right? So I've already shown you with the more complex documents in the beginning of the presentations that it is possible to embed like this nested documents and arrays as part of your document. And in many cases, that actually makes it possible for you not to require relations between documents. I wouldn't say that's always the case, but in many cases, it is important to remember that data that belongs together is also stored together. As an example, if you, some applications, you'd have a person class. A person class will have multiple addresses, and from an application's point of view, those things are usually represented as one specific object, which in this case transfers quite well to the database, where you can store the data that belongs together in one document. And this is kind of important because, as I said, there's no joins, at least not in a normal query language. But it also means that the data that belongs together is stored together on disk. And if it's stored together, it makes it quite a bit faster to query, right? As an example, if you do a join between a person and all of its addresses, it can be 4 or 5. Those 4 or 5 addresses might be stored all across the disk. You don't necessarily know how they ended up there, right? Whereas if you would do the query in MongoDB, because you could embed all those addresses with a person, it is a single query and it's stored in one location, which tends to be a much faster operation than having to read it all over the place. Now, of course, there are also some negatives about that. It makes it harder to sometimes update specific sub-elements in here. All right, so the schema considerations that you take, I've mentioned a few times that you don't have to create a schema up front, but you really should think about how your data look like, is depending on what sort of access patterns you have. If I do lots of reads and lots of write for one specific document, that's probably not a good way of doing it. You need to look at what type of queries you have, what kind of updates you need to do. Talking about how to design a good schema for MongoDB is going to take me 3 hours to do. I've just been noticed I only have 15 minutes left, so too bad, not for now. But I'm happy to answer questions about it later. All right, so just as a quick thing, have any of you ever looked at Magento's database schema? I don't want to pick on Magento here, but because it's just a good example of this specific database pattern, right? This entity attribute value where, because it being an e-commerce platform, you store fields in different tables depending on the data type, how they're linked to this specific product in this case. And that makes it sometimes really difficult to figure out what goes on in your application. And Magento is by far not the only system that does anything like this. But in document database like MongoDB, you just store whatever you want in one document, right? And you don't have to do anything about it. It makes it much more obvious to see what actually happens here. And on this page, I have so much space left that I can include a picture of an elephant. And you know, elephants are kind of big, so what can I say? Now, I've mentioned that it isn't necessarily necessary to create a schema up front, but if you want to enforce a schema, that is something you can do, however. There's two different ways of doing that. There's this very simple way where you attach a validator to a collection. This is an example what you would use on the MongoDB shell. So we are modifying the collection whiskey and we're adding a validator here. The validator says, well, each document needs to have at least these two fields. They need to have name and age. And name needs to be of type integer. It needs to be a number. And, sorry, I say that the wrong way around. Name needs to be of type string, a text, and age needs to be a number. So this is a very simple validator that makes sure that anytime we insert or update a document in a collection, if those types do not match with what you're trying to store, the database will refuse to then update or store the document, and you'll get an exception back in your application, which is a very simple way of still sort of defining a schema. Now, this simple validator is a bit older. We since then have added support for JSON schema, which is a whole lot more powerful, but also a whole lot more complicated to actually set up. But it will extend enforcing specific types that you can set which fields may not exist, or you can create a collection of all the fields that maximally can exist in a document. You can set up ranges for the values of fields, like what I've done here for the age field. The minimum value has to be 3 for it to be valid, and so on and so on. We implement, I think, draft 4 of JSON schema, in case you know how JSON schema works. Again, there's a lot more to this than just this slide. Just wanted to show you that, yes, it is actually possible in MongoDB to set up a schema and make it almost well, as enforceable as what you get in a relational database. All right, so a little bit about indexes. I've already said they're just as important as in relational databases. There's always a default one on _ID. They can be set on single fields, compound keys, like you'd expect from a relational database, or on these nested fields, like you remember the attributes.h from an earlier slide. But as usual, indexes also at overhead, right? If you create more indexes need to be updated when you insert, delete, or update a document. To create an index, this is the only slide where I sort of compare how to do it among the 3 different ways. Doing it on a MongoDB shell is probably where most people would create indexes. It runs like a little bit of a JavaScript kind of language in there, where you call create index. If you want to do it in the driver without having the library loaded, you can see that gets quite a bit more complicated, right? You need to run commands and stuff like that, where you need to set specific fields, and they all need to be the exact same format. Most of you will not use that way of doing it. Instead, you'd either use the shell or the library. And what you do on the library is very similar to what you would do on the shell. You call the create index method with the 2 fields here, the 1 field here, validation code being 1, and we also set the index to be a sparse index. So sparse index is something that you won't see in a relational database. Think of it as an index that only includes documents where a specific field is set. As I said before, a document doesn't necessarily have to have all the fields like other documents in a collection. So with a sparse index, you make sure you don't actually index these documents. So basically, what you say, comparing to a relational database, you do not index any documents where that specific field would be null, for example. All right, so it's important, of course, to figure out whether indexes are actually being used. And for that, we use explain, like you would use in MySQL as well. The output that you get from that looks a little bit different, but I think it's, if you look at this well enough, often enough, it actually becomes quite obvious what it is doing. So the way how you read these explains is you start at the most deep nested level, and then you walk your way up. So in this case, there's an input stage here, and the input stage says a stage, it's an IX scan. That stands for index scan. That basically means that we're being able to answer this query by using an index. If you get the words call scan there, stands for collection scan, that is your MySQL full table scan, which you want to avoid. Depending on what kind of query you run, what kind of indexes you have, there could be multiple stages. In most cases, you'd see an index scan combined with a fetch. And a fetch is basically means from all the documents that we have found through doing the query with the index, we now need to fetch the whole document to be able to return that to the user. Hence, we need to do a fetch stage to fetch all these documents. In some cases, it is possible to not have to do the fetch, because in some cases, it is possible that the index already contains all the fields that you want to see. So the fetch isn't necessary anymore. We call them covered queries, and I'm sure there's a similar thing in MySQL as well there. Besides having normal indexes, we also have a bunch of special indexes. We have geospatial indexes, which are a really nice way of finding points near a geographical point. I like doing geospatial stuff. If you remember, my first slide says I love maps. This feature in MongoDB, finding things on maps, works really well for me, so I'm quite a fan of this. There's also full-text search indexes. They are meant to provide full-text search capabilities for 80% of the cases that you might want to do that. For anything more complicated, probably using Elasticsearch or something like that is a much better way. But for most simple websites, the full-text search index capabilities in MongoDB are pretty good, and they work quite easily, and they support multiple languages, which is kind of handy. All right, so I mentioned the query language, and when I was doing so, I also said that there's another possibility of doing queries against MongoDB with the aggregation framework. The aggregation framework is sort of a replacement for what people used to use MapReduce jobs for. So MapReduce in MongoDB is running in JavaScript. It's not particularly fast. It can't make use of indexes, and we really rather won't talk about it anymore because it's not a particularly great feature. Instead, as an alternative, we have something called the aggregation framework or aggregation pipeline. And what this does, it defines a series of operations that you run in sequence on an input stream, which is usually a find query. It's very similar to what you do on the command line with Unix command line commands, right? So psax finds you all the processes. With grab MongoDB, we only find the Mongo processes, and then with the head -1, we only take the first one. So that's your limit one, really. So that is in the same way is how the aggregation framework works. There's different stages that do different operations. So to have a bit of an example here, if we have a big collection of all the beers I've tried, for that I have a big collection storing all this data in my collection. So I have the beer types in there, the brewery country, the ABV, which is how alcoholic it is, and how much I like the beer. And by having all of these in a collection, I can now run queries against this. Now, if I want to do anything like groups or doing like aggregations that you would do in a relational database, for that you use the aggregation framework. So there's many different stages that there are. There's match, which is find. Project allows you to only have different fields in there. It's like instead of the select star, it's the select field 1, field 2. Group is for making groups, grouping things together in one specific element. Unwind, that's the opposite of a group. As MongoDB data can store arrays, unwind will unwind the array and emit a document per array element of that array. Sample gives you 1,000 random documents out of a collection, which is kind of handy sometimes to test out your queries with, because if you have 10 million documents, you don't want to run the aggregation on that and figure out that you made a mistake, because it takes a lot more time. So sample is useful there. And there's a whole bunch of more specialized options as well. So as a typical example, how you would approach this is that if people would ask me, what is your favorite German beer? Well, how would you think about that? Well, I want to find all the beers that are German and sort them by my rating, descendingly, so the highest rated goes first, and then I take the first result that comes back from this, right? So, like I said, you find all the German beers, sort by rating descendingly, and then limit by 1. And that is the exact same stages that you would also use in aggregation framework. So I'm doing this on the shell. The syntax in PHP is pretty much the same, where we do a match, which is your find query. So I'm finding all the documents where brewery country matches Germany. I do a sort. So I sort by the rating score, -1 being descendingly, so the highest goes first. And then we take the limit 1 to take the first one that comes through. And that tells me what is my most famous German beer. That ends up being the Argentines Eisbock, in case you cared. Surprise? No? It's quite a nice beer. You should try it if you can find it. Anyway, we can talk about beer at a totally different time. Let's not do that right now. But the aggregation framework, and I know this slide is going to be way too complicated to explain. I just wanted to show you that it is really, really powerful. So if I want to have an overview of the number of beers per X, then we can do things like this. So if I want to show how many beers of a specific type I've had, we can use sort by count, which is a sort and a count for that specific type. Or same things like from countries where I have had the most beers from. You can do that. Or you can even create kind of histograms. So a histogram that stores the beers according per range of how much alcohol they contain. I understand going through this is a bit too tricky. If you want to have a good look at this again, the slides will be shared later for you to have a look at exactly how this works. But I can show you the results as well in case you want, is where well, the first one, the ABV one, shows you a histogram between 0 and 2, I've had 64 beers. Between 4 and 6, I had 2,200 beers. Those are old numbers, though. But again, let's not talk about beer too much. But yeah, it shows you in quite a simple, powerful query. It does do quite a lot, right? It creates like all the information that you sort of need to make quite a good of an indication of, in this case, which beers I like and which beers I don't like very much. Yeah. All right, so the last thing I want to touch on very briefly, because I don't have very much time, is replication. MongoDB being a non-relational database, most of those have been created for run in things like cloud environments. And cloud environments usually have the nasty problem of sometimes breaking your network connection, or your machine needs to be updated because there's some hardware failure, or there's a bug in Xen and things like that, right? Maintenance on cloud services like AWS just needs to happen. This is why most non-relational databases will be designed for being a distributed set of database servers, so that if one goes down, another one can take over. So in MongoDB, this is implemented in something we call replication. And replication is a cluster of n servers. N is a number between 1 and 50. And it is set up in such a way that the PHP driver knows where to send all the queries to. It figures out what is the primary node. The primary node is the one you can do updates on, writes, updates, and deletes. The secondary nodes will get the data after it has been applied to the primary node. So it is possible to read from the secondary nodes, but if you do so, the data can be slightly out of date sometimes. But the most interesting is that this replica set on its own makes sure that if one server goes down, another one takes over as primary node. There's no intervention required by you as a user or a database administrator to do anything about it. So in a diagram, it sort of looks like this. When you start this up, in this case we have 3 nodes, they elect a primary node, in this case it would be member 3. The driver figures out that, oh, I know what the primary node is, I set all my updates and insert queries to that one. It will also, by default, read all the information, do all the find queries of that same primary node, unless you tell it that it's okay to read from secondary nodes. But as data inserts get replicated from the primary node to the 2 secondary nodes, member 1 and member 2 in this case, that data can sometimes be outdated. So although this is a self-healing mechanism, you do need to be a little bit concerned sometimes about, is it okay for my application to read from secondary nodes? In most cases, the answer is going to be no. But the idea here is that it isn't there for read scaling, but it's there to make sure for automatic failover. All right. So if you don't want to mess any of these things yourself, there's something called MongoDB Atlas, which runs replica sets in the cloud. We provide it as a service. If you want to play with this and all its features, there's a free tier, which doesn't cost you any money at all. I think if you want to start with things like replica sets, or just want to try out MongoDB without having to install the server and maintain all those things yourself on your servers, have a look at Atlas and play around with it. If you like it, if maybe you want to upgrade to a paid service. If not, just delete your data, and no hard feelings there either. All right, that's what I had to talk about. I have how many minutes for queries? Questions? No questions.
Unfortunately,
no time for questions. Let me finish though. So give me 1 second, because I have one more slide. If you scan this QR code, you'll go to a URL where you can find the slides for you to look at later. If you have any questions, feel free to come and find me. I'll be around all day. I will be mostly hanging out in the speaker's lounge, I think, or in any case, come to talk to me. Any questions you have. With having said that, thank you very much. I hope this was useful to you.